Hey guys, welcome back. So today we're going to be dealing with two-step inequalities. Let's go ahead and write down today's objective. Today's objective is I can solve and graph two-step inequalities. Now before we actually start solving and graphing two-step inequalities, there's a couple rules that we need to know about inequalities. And instead of me just actually telling you those rules, we're going to do this little activity to help see if you can actually figure out on your own. Okay? Now we're going to start in this box right here. We're going to start with an inequality. 10 is less than 15. Now, this is a true statement because 10 is actually less than 15. So down here, I'm going to circle true. All right. Now, we're going to do the first box together. In this first box, we're going to take the 10 is less than 15. And we're going to, it says right here, to add 5. So we're going to add 5 to both sides of this inequality. 10 plus 5 is going to get you 15. 15 plus 5 is going to get you 20. We get 15 is less than 20. Now, this is also true. So we're going to go down here and we're going to circle true. Okay? Now, there's 5 more operations. So let's go ahead and put 10 is less than 15 in all of these. All right? And we're going to do what it says above the box. We're going to do that, and then we're going to see if it's true or false. So in the next one, you're going to subtract 5 from both sides of the inequality. The next one, we're going to multiply by 5. We're going to then multiply by negative 5. Divide by 5, and then we're going to divide by negative 5. Now, what you need to do is put your result in the space down here, and then you're going to circle if the result is true or if the result is false. Okay, it's going to come up in a second, so make sure that you do this before you answer the question. Go ahead and do that right now. Alright guys, so hopefully you noticed which ones turned out to be false. That is the rule that we're going to be talking about in a second. So let's just see what winds up happening. Over here, when you subtract 5 from both sides, you get 5 is less than 10. And that right there is going to be true, because 5 is less than 10. For the next one after that, we had to multiply by 5. That got us 50 is less than 75. We wound up with another true statement right there. Okay. Now for the next one, we multiplied by negative 5. All right. So that's pretty much the same thing we have here, but we're just going to have the negatives with them. So negative 50 is less than negative 75. That is not true. I would rather owe you 50 than owe you 75. That makes the negative 50 bigger than the negative 75. So this one wound up being false. All right. For the next one, when you divide by 5, you wind up getting 2 is less than 3. This is true. So at the bottom over here, I circle true. And then for the last one, we see that negative 2 is less than negative 3. This is not true because, again, I would rather owe you $2 than owe you $3, so that's why the negative 2 is bigger. So this winds up being false. Okay? Now, hopefully you noticed that when you multiplied or divided by a negative number, that caused you to have a false statement. So how can I make this statement true? Well, you got to take that inequality, you got to turn it around to make it a greater than symbol. Then that would make it true. Same thing over here. If we made that a greater than symbol, that would make it true. Okay? The specific rule that you need to know, let's go ahead and write this down, is when you multiply or divide by a negative number, the inequality symbol reverses. Okay? So go ahead and write that down. We're going to come up with a couple, I'm going to show you a couple of examples, and then we're going to start doing some real examples. So for the first one, we have negative 2x is less than 10. All right. Now, in this one, we have negative 2 times x. The opposite of multiplying by negative 2 is dividing by negative 2. Okay. Now, just like we said over here, whenever we divide by negative, to make this actually a true statement, you have to change that to a greater than symbol. So this symbol right here needs to be changed to a greater than symbol. And then you wind up getting x is greater than negative 5. Okay, over here, in this next one, we have x over negative 5 is greater than or equal to 4. How do we get rid of that negative 5? Well, we got to multiply it both sides by negative 5. Now over here, again, when we multiplied by negative 5, this wound up being a false statement. If we wanted to make this true, we had to flip the sign. So over here, this greater or equal to symbol will actually be flipped so that it winds up being less than or equal to. Now you're just going to have x on the left side. On the right side, we wind up with negative 20. All right? So it's still up at the top over here if you need to write it down. And again, if you need to press pause, you can press pause at any time. Now, number 1, let's go ahead and write this down. We have 6x minus 7 is less than 41. What we need to do is we need to get x by itself. This right here is a two-step inequality. So we have two numbers along with the 6. Along with the x, we have 6 and negative 7. Who's furthest away from x? It's the negative 7. So let's get rid of that one first. Let's add 7 to both sides. 7s will cancel over here, and then we're just going to be left with 6x is less than 41. Okay? Now, to get x by itself this time, we're going to have to divide by 6. Now, we are dividing by a positive number, which is okay, and you don't have to worry about changing any signs. So this less than symbol is going to stay the same. The 6's cancel out, leaving you with x is less than 48 divided by 6 is 8. Okay? So, again, did we have to change the sign? No, because of the fact that we divide by a positive number. All right, so now we're going to go ahead and put that 8 on the number line, and we're going to give it a open circle. All right, why is it an open circle? Well, recall that we do not have an or equal to bar. This is what an or equal to bar looks like. We don't have one of those, so therefore it is an open circle. All right, now we have to find out what side to shade, and we did this before in our inequality problems. So we're going to go ahead and check. How do we check? Well, we're going to put x. We're going to put a test point in for x. And remember, I want you guys to use negative 100 and 100 to help you make sure that you get the right answer. So if we put 100 in there, is 100 less than 8? The answer is no. So now let's go ahead and try negative 100. Is negative 100 less than 8? The answer is yes. So negative 100 is on this side of the number line, so we're going to go ahead and shade that side. Okay? Now let's go ahead and look at number 2. Number 2, we have negative 6x minus 7 is less than 41. You might think that it's the same, but it is not, because over here we had a positive 6, over here we have a negative 6. So the steps are kind of going to be the same. Who's furthest away from the x? The negative 7, so we're going to add 7 to both sides. 7's cancel out. We get negative 6x is less than 48. Now, we're going to divide this time again, but when we divide, negative 6 over negative 6, of course, cancel out, but we divided by a negative. And up here, you guys remember the rule. When you divide by a negative, you need to switch the symbol. So this less than symbol changes into a greater than symbol. Make sure that's the first thing you do before you do any math, because the fact that you don't want to forget that this is going to change. Because if you don't change it, your graph is going to be wrong. Okay? So x stays on the left side. The right side, we're going to wind up getting negative 8. So now our answers look totally different. That little negative right there made these answers totally different. Okay? Now, we're going to go ahead and put negative 8 in there. And then we're going to give it another open circle because there is no or equal to bar. Then we're going to check by putting in a test point. All right? So let's go ahead. For x, let's go ahead and put in there negative 100. Is negative 100 bigger than negative 8? The answer is no. So we're going to erase that. And then we're going to put 100. Is 100 bigger than negative 8? The answer is yes. Okay, where is 100? It's on this side over here. So we're going to shade that side. Okay, now again, if you need to press pause so you can write this all down, go for it. Just a recap for you. Again, over here we divided by positive. Nothing happened to the inequality. Over here you divide by negative. You do have to change the position of it. This less than, it's pointing that way, turns into a greater than, which is pointing that way. Okay. All right, number 3. Number 3 we're going to do together. We have negative 9 is greater or equal to x over 2 plus, x over negative 2 plus 6. Okay, so who is furthest away from x? The negative 2 or the 6? All right, the 6 is furthest away, so let's get rid of that 6. How are we going to get rid of it? Well, let's go ahead and subtract 6 from both sides. Negative 6 and positive 6 will cancel. All right, over here, negative 9 and negative 6, that's going to get you a negative 15. Everything else will just come down. So negative 15 is greater or equal to x minus 2. All right, now, how do we get x by itself? Well, in this one, it's being divided by negative 2. The opposite of dividing is multiplying. So let's multiply both sides by negative 2. Over here, these cancel. Okay, now remember the rule. The rule is if you multiply or divide by a negative, you have to change the sign. In this case, we're multiplying by a negative. So this greater than symbol needs to change to a less than or equal to symbol. Okay? Now, on this side, -2 times a -15, that gets you a positive 30. On the right side, we still have just x. So 30 is less than or equal to x. Okay? So let's go ahead and put that 30 on there. Now, we do have an or equal to bar right here. So remember, that means that we are including 30. And because we are including 30, we have to signify that by putting a closed circle so it's all colored in. All right? So let's go ahead and use our test point right now. So our test point, again, we're going to put in, let's start with -100. Is 30 smaller than -100? No, it is not. So then we're going to go ahead and try the next one, which is a +100. Is 30 smaller than +100? The answer is yes. So we're going to shade this side because that's the side that 100 winds up being on. All right. Okay, let's take a look at the next one. Number 4 is -4x minus 11 is less than or equal to 9. I want you guys to go ahead and try this one on your own. The question is going to pop up in a second. So go ahead. All right, guys, hopefully you got the correct answer. But just in case you got the wrong answer, I'm going to go ahead and go through it a little quickly, though. So over here we have -11, all right? That's furthest away from x, so I'm going to add 11 to both sides. 11's cancel. We'll have -4x is less than or equal to 20. Now, over here, we're going to have to divide by negative. And remember, anytime you divide by a negative, you have to change the symbol. And again, that's the first thing you need to do before you do anything else. So let's change that less than or equal to a greater than or equal to. Okay? On the left side, the -4's cancel, so you'll just be left with x. On the right side, 20 divided by -4 is a -5. All right? So let's go ahead and put that -5 on the number line. All right? And we have a closed circle because there is an or equal to bar. All right? The test point I started out with was -100. Is -100 bigger than -5? The answer is no. So let me put 100 in there. Is 100 bigger than -5? Yes. Where is 100? 100 is on this side of the number line, so I'm going to shade that side of the number line. All right. Again, hopefully you got that correctly. If you didn't, please go ahead and correct it at this moment. And again, if you need to press pause, go ahead and press pause. All right. Number 5. Number 5 is 20 is less than or equal to 2x plus 6. I'm going to give you guys a second to do that one. The questions are going to pop up and you're going to have to answer them. Go ahead and do that right now. All right, guys. So again, hopefully you got that correct. If you didn't, it's okay. Let's go ahead and talk about it. So first thing I'm going to do is I'm going to subtract 26 from both sides. 26's cancel. So I'm going to have over here 20 minus 26. Excuse me. 20 minus 26 is 6. -6. -6 is less than or equal to 2x. Now over here I have to divide by 2 on both sides. Now we are dividing by a positive number. What that means is that the symbol does not change. So over here this is going to wind up being -3, and then you're going to have -3 is less than or equal to x. Okay. Now we're going to go ahead and graph this. We'll put the -3 with a closed circle. The test point that works for me is +100. -3 is smaller than 100. 100 is on this side, so I'm going to shade that side. Okay? All right, here's your next problem. Go ahead and do this one on your own. We have 1/2 times this binomial, 12x minus 6, and it's less than or equal to 15. Go ahead and solve that one. All right, guys, so we're going to start out by distributing the 1/2 onto these two terms in here. All right, so 1/2 of 12 is going to be 6x. 1/2 of -6 is -3. All right, now we're going to go ahead and we're going to add 3 to both sides. 3's cancel. 6x is less than or equal to 18. All right, finally, we're going to divide by 6 on both sides. We're going to get x is less than or equal to 3. We did not change the sign because of the fact that we had divided by a positive number, so we don't have to worry about changing any signs. There's my 3. Let's go ahead and put some test points in there. All right, the first test point is 100. Didn't work. Here's my -100. -100 is smaller than 3, and -100 is on this side, so I'm going to shade that side. Okay, last one. All right, so go ahead and do this one. All right, guys, so for this one, we have we have 2 minus 15. Those two things are like terms, so we're going to go ahead and combine them. And on this side, these two have x's in them. We're going to combine those. All right, so we're going to get negative 13 is less than negative 2x minus 3. Okay, so let's go ahead and get the x by itself. The thing furthest away from x is this negative 3, so let's add 3 to both sides. Those cancel. We get negative 10 is less than negative 2x. All right, how do we get rid of this? Well, we're going to divide both sides by negative 2. That's going to cancel out the negative 2. And again, dividing by negative changes the sign to a greater than symbol. You wind up getting 5 is greater than x. So we'll put our 5 with a open circle because there is no or equal to bar. All right. My test point that works winds up being negative 100. Negative 100 is on that side, so I'm going to shade that side. All right, guys. See you tomorrow.